Hey everybody, it's Mr. N here, and we're doing another video. This is on the chain rule, some more examples. Now, we talked about what the chain rule does, and basically, to put it in simple terms, it's when you have a composition of functions, you have to take the derivatives of all parts. So that's what we're going to deal with here, and for this first one, let's go ahead and just get started with this. And on this first one, we've got f of x equals the fourth root of negative 3x to the fourth minus 2. So basically, we can rewrite this to be negative 3x to the fourth minus 2 to the 1/4 power. Now, that'll help us in taking the derivative. So by taking the derivative, we're going to take f prime of x, and here we're going to take the derivative, and often I've put this to you guys in class as a box, and this is the box to the 1/4. So this will be 1/4 times whatever is in this box. Now this will be to the negative 3/4 power. And now I have to take the derivative of what's inside this box. That's the second function. And we know that it's negative 3x to the fourth minus 2, so I multiply this by negative 12x cubed. Now it's just a matter of cleaning this whole thing up. So we'll get f prime of x equals, and then we can reduce this a bit right here, and we'll say negative 3x cubed, and we'll put this part right here, this box part, on the bottom because it's negative 3/4, and I'll just say that it's negative 3x to the fourth minus 2 to the positive 3/4. Now you can just go ahead and leave it like that, and we can move on to the next problem. If you have something like this on the AP test, they may rewrite this bottom part to be the fourth root of negative 3x to the fourth minus 2 to the third power. If you're looking for your answers on the multiple choice, they might show it in that format instead. All right, taking a look at our second problem here. On this one, we're going to take y prime, but again, see that this is negative 2, and this would be my box right here. So we have y prime equals, and this would be negative 2x negative x to the fourth power minus 3. That's the box part. And then this would be to the negative 3 power. Now I need to chain rule it and take the derivative of that other function, which is the negative x to the fourth minus 3. And this becomes negative 4x cubed. Now again, let's just clean this up a little bit. I can say that this is going to be 8x cubed, and this will be negative x to the fourth minus 3 to the negative 3. If you wanted to clean it up further, you could say 8x cubed over negative x to the fourth minus 3, and we can make that cubed like that. All right, moving on to number 3. So for this one, we've got the same situation here. This is a box right here. I have to do that one. This one is to the first power, so I don't need to worry about the chain rule. Even though you are applying the chain rule, you won't see it in that part. So we're going to go ahead and take the derivative here, and when we take the derivative of this one, we are going to need the quotient rule. So we'll have the bottom, which is 3x to the fourth minus 2, times the derivative of the top. Now the derivative of the top will be 5 times this x cubed plus 4 to the fourth power. Now I got to take the derivative of that inside part, which is going to end up being 3x squared. Now minus the top, which is this x cubed plus 4 to the fifth power, times the derivative of the bottom, and that's just going to be 12x to the third power. Now, all of this goes over this bottom part because we are using the quotient rule squared. Now, cleaning this up is kind of a mess. What you can do is, because they both have this, let me choose a different color so you could see, they have this x cubed plus 4 in common, so I could take that part of it out. They also have, here we've got a 3, and I could take that out of there as well, along with an x squared and an x squared. So I can take those things out when I'm trying to reduce this. And it's good practice for us to reduce it. So let's just go ahead and reduce it a little bit. So we're going to take out the 3x squared, and then this x cubed plus 4, and I could take 4 of these out. And I'm going to be left with a 5 here, 3x to the fourth minus 2, minus 4x times x cubed plus 4, all over this 3x to the fourth minus 2 squared. Cleaning this up a little bit further by foiling here, combining like terms, we will end up with 3x squared times x cubed plus 4 to the fourth power. And all of this, when you FOIL it out, when you factor it out, or distribute it, I should say, and then combine like terms, you'll end up with 11x to the fourth minus 16x minus 10 all over this 3x to the fourth minus 2 squared. And we'll just leave it in that form. Okay, moving on to the next problem. So for the next problem, we have, we've got a box inside a box. You see that? So we've got almost kind of like a double chain rule going on. So let's see what we're going to do. First, we're going to do that outer one. So y prime is going to be 4, and we'll have this x plus 5 to the fifth minus 1, that whole thing to the third power. Now I got to take the derivative of that, so times, this will be 5x plus 5 to the fourth power, times, then I've got to take the derivative of this, which is going to be 1. So now, cleaning all of this up, we're going to get y prime equals, this will be 20, and we'll have the x, this is the 4 times the 5, and now we'll have that x plus 5 to the fourth power, and this will be times this x plus 5 to the fifth minus 1. All right, let's scroll this up, and we can see what the next problems are. Over here, we have this derivative, and we're going to need to use the product rule here. So for this one, let's go ahead and take a look at how we're going to apply the product rule. And this is going to be our first, this is going to be our second. And in fact, this one will have a chain rule. This second one right here will have a chain rule involved. So f prime of x will be, when we start taking this derivative, it's going to be the first. So this will be 4x to the fifth minus 1 times the derivative of the second. Now remember, this is that to the 1/3, if you wanted to write it that way to help you out. So this will be 1/3 x plus 1. Now subtract 1, this will end up being negative 2/3. Now chain rule this, so it'll be times 1, because the derivative of x is 1. So first times the derivative of second plus the second, now we've got this x plus 1 to the 1/3 times the derivative of the first, so this will end up just being 20x to the fourth. All right, now technically we can just kind of finish at this point, but I do want you to try to simplify it just so that you could see what happens here. All right, so the way to simplify this is we are going to take out this right here. So if I take that out, I'll have the x plus 1 to the negative 2/3. I will be left with, inside a big bracket there, I'll have this 1/3. I will have the 4x to the fifth minus the 1. And that's on this side. Now on the other side, where this plus was, I'll end up with, now I took negative 2/3 out, I'm just going to end up with 1 whole one of these times this 20x to the fourth. And that was the trick I wanted you to see there. You can always take out that larger negative one, and then it should clean this side up right there fairly well. So you can go ahead at this point and distribute all this, and then we will end up with, on this one we'll have, we can rewrite it if you want, put that on the bottom. So we'll have this x plus 1 to the 2/3 on the bottom right here. All I did was move that to down to the bottom there to the denominator. And the top will end up being this 1/3 times this 4x to the fifth minus 1 plus this part right here, which will be 20x to the fifth plus 20x to the fourth. Now I can multiply the top and bottom by 3 over 3 to get rid of that fraction, and I'll have f prime of x equaling this 4x to the fifth minus 1 plus the 20x to the fifth, or that'll be 60 now, plus 60x to the fourth, all over this 3 times x plus 1 to the 2/3. You can take this a step further and combine the like terms, and you'll end up with f prime of x equaling, this will end up being 64x to the fifth, because here's 60x to the fifth and there's a 4. So 64x to the fifth, and then you'll have plus 60x to the fourth minus the 1 all over this 3 times x plus 1 to the 2/3. That's a crazy one to simplify, but that's how it would be done. All right, moving on to the next problem. Here we go. So this is similar in a sense in that we are going to do a product rule here again, and let's see what we end up with. So y prime is going to be negative x to the fourth minus 1, that's first, this is to the 1/2, times the derivative of the second, which would just be negative 1, plus the second, which is negative x minus 2, times the derivative of the first. Remember, this is to the 1/2 power, so this will be 1/2 negative x to the fourth minus 1 to the negative 1/2. Now I have to apply the chain rule to that, so that's negative 4x cubed right there. Because this was my box, I did the derivative of that part, then I got to do the derivative of the inner part, because that's the composition. So we end up with y prime equaling, now I could take out this negative x to the fourth minus 1. I could take out let's do the, remember we said the little trick was to take the largest negative part of it. So we'll take out that negative 1/2, and I'll be left with negative x to the fourth minus 1, and I'll be left with 1 whole one of those times negative 1, plus over here we're going to end up with negative 2x cubed times this negative x minus 2. And cleaning this up a step further and combining like terms and everything, you'll end up on the top with x to the fourth plus 1 plus 2x to the fourth plus 4x cubed all over this negative x to the fourth minus 1, and this will be to the 1/2 power. You can even take this a step further and say this is 3x to the fourth plus 4x cubed plus 1 over this negative x to the fourth minus 1 to the 1/2 power. And that would be your answer. All right, so now moving on to number 7 and number 8. Let's take a look at these. So for this one, we have a trig function, and we've got the secant x. So on this, remember, when you take the derivative of secant, that's going to be secant x tangent x. So that's, put that in a box, put that in a box, put that in a box. So y prime will be the secant box times tangent box. But now we have to apply the chain rule and take the derivative of what's in this box. So that's your present right there, the derivative of what's in that box. And that one, in this case, will be 8x cubed. So we end up with y prime being 8x cubed times the secant of 2x to the fourth times the tangent of 2x to the fourth. And that's it. And you can just leave the answer like that. And this is to the fourth power. So let's make sure we kind of see that. Let me fix that here, that this is to the fourth power up there. Okay. All right, for the next one, it's kind of the same concept here, and in this case we've got the sign, and here's our box. So what's the derivative of the sign? Well, that would be cosine. So this is the cosine of what's in this box, but then we have to take that as our chain rule, and that's going to be the 12x squared. So we end up with f prime of x being 12 x squared times the cosine of this box, which was 4x cubed. All right, let's see what we got next. On this one, let's enlarge these a little bit so we can take a look at these. The first one is y equals the cotangent of the cube root of, okay, again, this is a box inside a box. So first you start with this cotangent of whatever this box is, take the derivative of this cotangent, then we have to take the derivative of that box. But that box has an inner box in it because it's something to the 1/3. So first let's start with the cotangent, y prime. The derivative of cotangent is negative cosecant squared, and it's going to be this box, which is the third root of negative 5x cubed minus 2. Now I need to take the derivative of that. Remember, this is negative 5x cubed minus 2 to the 1/3 power. If you take this derivative, and that's what we're going to multiply it by, we could do this on the side here. That's going to be 1/3 of this box to the negative 2/3, now times the derivative of that box. So I'm chain ruling it all. So we end up with negative 15x squared there. So all of this is going to be multiplied by this 1/3, and this will be negative 5x cubed minus 2 to the negative 2/3 times this negative 15x squared. So that's the whole thing. We can clean this up, and we'll end up with some of these things reduced. That reduces with that to give you a 5 here. And then you have the x cubed, and we can put that negative right here. With that negative, it goes away. So we end up with the 5x squared, this cosecant squared of the cube root of negative 5x cubed minus 2. And then we could put this part on the bottom right here as the negative 5x cubed minus 2. And we could just say that that's to the positive 2/3, or you could say the cube root of that squared. We're just going to leave it like that. All right, for the next one, again, you've got a box inside a box. So let's take a look. You've got the sign, and this is sine of a box in here, but this is to the 5th power. So this is its own box. And then in here, you've got another box inside of it. So taking the derivative here, you've got multiple functions. You've got the sine function, then you've got, so you could think of that as your f of x, and you've got a g of x in here and an h of x in there. So you've got multiple compositions going on, which is why we need this chain rule. So over here, we'll have 5, and then this box to the 4th. Well, what's in this box? Well, it's the sine. So I have to take the derivative of sine. Well, that would be the cosine of whatever's in that box of it. And then I got to take the derivative of what's in that one. Well, that box is the 7x, so times the 7. So you end up with f prime of x being 5, and this box was the sine of 7x, times, over here you had the cosine of 7x, times 7. Because this was the box right here, and this was the big box right there. All right, cleaning this up. That one may have been a tough one. You might need to take a look at it again to see how I did it, but basically rewrite this as the sine of 7x to the 5th power. You start with this one, then the derivatives of that and that. That's the chain rule. Okay, so then cleaning this up, you end up with 35 cosine 7x times the sine 7x to the 4th power. You can even rewrite this part right here as a sine 4 like that, 7x like it originally was. So either way is fine. Okay, moving on to the next problem. Number 11. Well, product rule again here is what we're going to have to do. So for the product rule here, let's go ahead and say this is our first times the second, but then you have boxes here, right, that you have to chain rule. So y prime is the first, times the derivative of the second. Derivative of cosine is negative sine 3x times this negative 3, or positive 3, sorry. That's the chain rule part. Then plus the second, which is the cosine of 3x, times the derivative of the first. Well, derivative of sine is going to be cosine 2x times the derivative of that, which is that 2. So let's just rewrite this a little bit, and we'll get negative 3 sine 2x sine 3x plus 2 cosine 2x cosine 3x. All right, let's take a look at number 12. For number 12, it says we have to use the table to answer the following questions. All right, so for the first part, we are given what f of x is at a couple values of x, negative 1 and 0. We're given the f prime of x, g of x, and g prime of x. All right, so for part A, the function p is given by p of x equals f of the sine of x. Find p prime of 0. Well, p prime of x is going to be f prime of whatever I have in here times that chain rule. So this is a sine of x, so I need f prime of the sine of x times the cosine of x. So remember, it's f prime, but then I have to chain rule the inside of it. So p prime of 0 ends up being f prime of the sine of 0 times the cosine of 0. Well, the sine of 0 is 0. The sine of 0 is 0, so that means I need f prime of 0 times the cosine of 0 is 1. Now I look on my table, f prime of 0 is 3. So this becomes 3 times 1, which is 3. All right, let's slide this up a little bit more. That's good enough right there. And let's take a look at the next problem. Now, it says the function p is given by that. Find p prime of 0. Again, we need to find p prime of x. And in this case, look, for this one right here, I have to use the product rule. So this is going to be first times the derivative of the second, which will be g prime of the cosine of x, times the derivative of cosine of x, which is negative sine x. I mean, you can even say times 1, right? Because you're chain ruling and you're multiplying that sine, that derivative of x, which is 1. But we're going to leave that out. Plus the second, g of cosine of x, times the derivative of the first, which is 2x. Now, plus, I have to take this whole derivative. This will be f prime of g of x, but I got to chain rule it, times g prime of x. So let's put in p prime of 0 and see what ends up happening. You'll get 0 times, well, whatever you get here is just going to be 0, plus g times cosine of 0 times 2 times 0. Oh, that's going to be 0 also. So this whole part cancels out because these x's are zeros. So it would be 0 plus f prime of g of 0 times g prime of 0. All right, let's see what this ends up being. F prime, well, what's g of 0? G of 0, I look up here, and it's going to be negative 1. Times, what's g prime of 0? G prime of 0 is a 4. So now I need the f prime of negative 1. Here's negative 1, here's f prime. That gives me 5 times the 4, which will give me 20 total as my answer. Okay, next question is very similar in nature. This time we need to find h prime of x of this function. Over here I need a quotient rule, so that'll be the bottom times the derivative of the top, which is f prime of x cubed, times this 3x squared, right? I chain ruled it, minus the top, which is f of x cubed, times the derivative of the bottom, which would just be g prime of x, all over g of x, this whole thing squared. So working this out, oh, plus, I forgot this part right here. We have to take the derivative of that. Derivative of sine is cosine of 3x times 3. Chain rule that. So now we need h prime of 0. So this becomes g of 0. Well, again, we put 0 in here. That whole thing goes away. So this is going to be 0 minus on that part, it'll be f of 0, because 0 cubed is 0, times g prime of 0 all over g of 0 squared, plus on here you're going to get the cosine when you put in 3 times 0 times the 3. Cosine of 0 is 1 times the 3. So you will end up in the end with f of 0, here's 0. When you put in 0, you're going to get negative 2. So this will be negative 2. And then g prime of 0, g prime at 0 is going to be 4. So times 4 all over g of 0. G of 0 is negative 1 squared, which gives you 1, plus, over here we ended up with a 3. So cleaning all this up, I just moved this up just a teeny bit, so let's do that. You will end up with, this will be 8 plus 3, which is 11 as your final answer. All right, hopefully that helped, and hopefully you understand the chain rule a little bit better, and now you can be chain rule masters. All right, so thanks for watching. Make sure you subscribe, and we'll see you in the next video.